All right, let's take a real quick look here at higher order derivatives. This shouldn't be too crazy. So let's just say we have y is equal to x to the fourth. Okay? So far we've been focusing on just taking what's called the first derivative. And right now we're just really focusing on kind of just taking derivatives. We did learn initially that derivatives is a rule for slope for functions. We know the first derivative tells us the slope. But we can take more than the first derivative. We can go beyond, and in future chapters we'll learn about what the second derivative tells us about a graph, and even as you get into higher levels of math, there's the third and fourth derivative have certain implications as well. But the derivative here, if y equals x to the fourth, which is not too difficult, if we just take the derivative, we've always just called it the derivative, and if you ever hear someone say, find the derivative, it just means the first derivative, okay? Because the reason why it's called the first derivative is because you can go beyond this and you can then take the second derivative, which all that means is the derivative of the first derivative. So notice I take the derivative here and it becomes 12x squared, okay? I can take the derivative of that and it becomes the third derivative. So notice what I did, I put y prime right there. This would be sometimes called y double prime as the second derivative, y triple prime as the third derivative. So it's going to be 24x is the third derivative. Usually after the triple prime, usually what they start doing is writing like this, y, and then a parenthesis with a 4 there, because it gets, if you wrote the 20th derivative, trying to write primes, it'd be kind of difficult to keep track here and count that. But the derivative of that, derivative of 24x is just 24, okay? And from there I could take the derivative again, the fifth derivative, and that would be equal to 0. And after that the derivative is just going to remain 0. The sixth derivative is 0, seventh derivative is 0, and so forth and so on. And so anyways, we went to 5 derivatives right there, but that's an example of finding a higher order derivative, okay? With certain ones, as this one starts x to the fourth and reduces, polynomial functions have that property as you take their derivative, they reduce in power as you go along. Other functions such as, for instance, let's say you had f of x equals sine x, that's not going to reduce in power. Let's just see what happens here. The derivative of that is equal to cosine x, that's the first derivative. The second derivative, make sure you can see my derivative sign right there, that's a little prime. My second derivative, f double prime, is equal to negative sine x. My third derivative, so the derivative of, the negative is a constant, it's going to go along for the ride, and the derivative of sine is cosine, so it's just going to be negative cosine x. The fourth derivative, I'll do my little parenthesis thing here, is going to be equal to, well, the negative again goes along for the ride, but the derivative of cosine is negative sine, so it's going to be like negative sine, that'll cancel out, and just be sine x. So I am now back to where I started. So, a sine or cosine like this is going to, have a repeating pattern, and it'll go, 4 times and then start over again. Okay? So, again, there's an example of, going beyond the first derivative. So if you're asked to find the third or fourth derivative, you should have an idea of what you're supposed to be doing.